What is JWT? The term JWT, or JSON Web Token, can refer to a few things. It can refer to the standard or the set of rules that defines a URL safe way to pass information between two parties. This information that is passed comes in the form of claims. And all a claim is a piece of information about some subject in the form of a key value pair. And so JWT could refer to this set of rules that defines how we pass claims, these key value pairs, between two parties. And not only that, it defines a way that we can do it securely and in a way that is tamper-proof. Not necessarily secretly, but securely. And I'll go into more detail about what I mean later. So that's one potential meaning when you hear JWT. But it can also refer to the JSON Web Token itself. The token is the string that is created that contains the claim information. And this string is what we actually pass between the two parties. And so these are the two potential meanings whenever you hear JSON Web Token or JWT. But primarily when you hear it, it'll be referring to the actual string token that contains the claim information. All right, so let's talk about the token itself. Here I am on jwt.io, and on the left-hand side here, we have an example of a JWT. A JWT is made up of three parts. The first part is the header, which is represented by this red text. So this header string is essentially a base 64 encoded string that if I were to take and decode it, say by running A to B on it, I would get this JSON string, alg hs256 type JWT. The same thing that we have over here. And so that's all it is. It's a base 64 encoded version of this JSON object. So what does this JSON object mean? So the header information of a JWT is essentially metadata about the JWT itself. Most likely you're going to see this type JWT, which is just telling it, hey, this is a JWT token, and the alg field, which defines the algorithm that was used to sign this JWT. And I'll go into signing later on when we talk about the signature portion. But that's pretty much it. The header part is this base 64 encoded version of this JSON object that contains metadata about the JWT itself. The second part of a JWT is the payload, or the actual data of the JWT, the claims. And that's represented by this purple text here. You might notice that the red part, the header, and the payload are separated by this period. And so if we were to take the base 64 encoded version of the payload and decoded it, you would notice a similar thing where we could basically read the information from the payload. Some of these are known as registered claims, which means these property names are actually special to the JWT standard. They actually mean something specific in the context of JSON Web Tokens. And so if I were to go down, let's say JTI, this represents the JWT ID. It's a unique identifier for this particular JWT. The next registered claim is the subclaim or subject. And this essentially identifies the principal or the participant that is the subject of the JWT. All of the other claims in the payload are usually statements about this particular subject. In this case, I just made this subject up, DevSage login token, but all of the other claims are probably, they have something to do with this particular login token, whether it's the expiration of the login or where this login token was generated or what time I'm allowed to use the token, and etc. The next registered claim here is the ISS claim, which stands for issuer. And this identifies the principal that created and issued this JWT. This is most likely going to be a URL of some kind if the JWT originated from a server, say from an authentication server. The next registered claim is the AUD claim, or audience. And this could be a string, probably an endpoint of some kind, or it could be an array of strings that identifies the recipients that this JWT is intended for. And so each principal or each participant that is intended to process this JWT must first identify itself with any of the values in this string or in this list. If the person or if the party that's trying to process this JWT is not in the audience, then that means this token should be rejected. It should not be processed any further. This field is a way to kind of limit who should be able to process this JWT. All right, the next registered claim is the IAT, which stands for issued at, and this is a timestamp in seconds. So this represents the time that the token was issued. That's pretty easy. All right, and the next registered claim is the NBF claim, or not before, and this is also a timestamp. In this case, this is Tuesday, June 4th, 2024. And this represents the time after which the token should be considered valid. In other words, if I try to process this token before June 4th, 2024, it should be rejected. This token is not valid until June 4th, 2024. And so this claim is usually a way to kind of limit the scope or time that a token is available to be processed. And a closely related claim, the last registered claim here, EXP, is the token expiration. And you probably already know what this does. It defines a particular timestamp, in this case, Friday, June 7th. Anytime after Friday, June 7th, if we try to process this particular token, it should be rejected because the token is expired. All right, and that pretty much covers it for these registered claims. And the thing about these claims are they're pretty much always optional. You don't have to define all of these all of the time. However, it's probably a good idea to at least always have an expiration, just so you have some mechanism for invalidating JWTs whenever you need to. And there's one claim here that we did not go over, which is the username claim. And this is not actually a registered claim. This is a private claim. This is just a claim I made up. So you can pass whatever information you want in the payload, whether it's a registered claim or a private claim. I could have, let's say I have, I don't know, age 27. I could do that. And you can pass, like I said, you can pass whatever information you want. However, one caveat is you should never consider any information inside of a JWT to be private or secret. Remember how I got from here to here? All we had to do was take this base 64 encoded string and we ran it through this A to B function, and it gave us exactly what was in the token. So this is just encoded. It's not encrypted or hashed. It's not meant to be indecipherable or undiscoverable. That's not the purpose of JWTs. The purpose is to be secure, not secret. Remember how I said that earlier? And that kind of ties into the last part of a JWT, which is the signature. And what the signature is essentially the result of running a SHA-256 hashing algorithm and passing in as the inputs to that algorithm the header, the base 64 encoded header, so this red piece, and the base 64 encoded payload, this purple piece. So basically what happens is it takes these two pieces, runs it through this SHA-256 hashing algorithm, and the output is going to be some unique hash. And this hash is concatenated to the end of the JWT as the signature. It's separated by this last dot. So each piece of the JWT is separated by a dot. It's going to be header, dot, base64 encoded payload, dot, signature, which is the output from this SHA-256 hash call. And so essentially, the value of this signature is directly dependent on the values of the header and the payload. And so if I were to change something in the header, for example, you would notice the red piece changes and also the blue piece changes because the header is an input to how the signature is generated. However, the purple piece stays the same. Likewise, if I were to change this back and I were to change something in the payload, the purple piece would change, and also the signature changes because the payload is an input to generating the signature. And it's going to generate a unique signature for a particular header payload combination. On top of that, since we're using SHA-256 as the hashing function, we can pass in a secret as well. In this case, my secret is DevSage123, but if I were to change it a little bit, you would notice that my signature changes with it. And so this is an additional way to kind of get a unique signature based off of a particular header payload combination. But where this secret really comes into play is when it comes to verifying the validity of a JWT, to verify that it hadn't been tampered with since it was issued. So let's say we have an authentication server that has a login endpoint. When a user enters the correct username and password, the authentication server generates a JWT and sends it back to the browser to be stored. And the browser, whenever it wants to make an authenticated request back to the server, would include this JWT in the request. But how does the server know that this JWT is actually valid? How does it know that it hasn't been tampered with? How does it even know that this JWT originated from the server in the first place? Well, it can verify the validity of the token by looking at the signature. The way it's going to do that is it's going to try to rebuild this signature from scratch and compare it to the signature that the browser sent. Because remember how this signature was generated. The signature is just generated by taking this header and payload and running it through the SHA-256 hashing algorithm. If we try to verify the token with a secret that wasn't used to sign it, let's say, for example, instead of 123, they tried to verify it with DevSage 458 as the secret. Well, what would happen is we would get a different signature than the signature that I originally sent. And so the code on the server is going to be like, something's not quite right here. Either the secret that was used to sign this token is not the same one I'm trying to use to verify it, or it could be that the secret is correct. However, the payload was tampered with. So let's say DevSage1234. I didn't send this. Let's say a hacker intercepted this JWT and modified the username to DevSage1234. What would happen is the base64 encoded payload would be changed, but let's say that the header and signature remain untampered. The server would then try to verify this bad token by rebuilding the signature. So it'll take the base64 encoded header and the payload combined with my secret, and it'll run it through the SHA-256 hashing function. And it would generate a signature that looks something like this. However, the signature that I originally sent them looked like this. And since these signatures differ, the server is going to be like, oh, okay, somebody tried some funny business. This token has been tampered with. I'm not going to accept it. And so that's what I kind of meant when I said JWTs are good for securely passing data, but not necessarily secretly passing data. All right, and I think that pretty much covers a broad overview of how JWTs work. If you like this video, please leave a like, leave a comment if you have any questions, subscribe if you want to see more web dev tutorials. But other than that, peace.